Assalamu alaikum warahmatullahi wabarakatuh. This is Dr. Ali El-Moursy, and we are in lecture number 19 for microprocessor. This is actually, we want to start using the conditional jump instruction and the compare instruction in order to implement the program control operations that we have in our high-level language. The first one to use, actually, we have in high-level language 4 directives or 4 paradigms that are the mostly used in the any programming language, any high-level programming language are using them. Those can be actually categorized into 4. We have if-else statements, we have for loops, we have while loops, we have switch cases. We will start today by learning how can I, from my knowledge of the conditional jump instructions and the compare instructions, how to merge them together or utilize them together in order to implement the for loop that we usually have in our high-level language. So in the example here, actually this is the table, this is the summary of what we have learned in our lecture number 18, part 2. Okay, this will summarize all the conditional branching instructions that you have. You have to know which branch is checking for which condition in the light of a comparison between 2 operands. Okay. 2 operands could be 2 registers, could be register and memory, could be register and immediate value, memory and immediate value, any flavor of those. This is actually our capabilities in the high-level language. Right now, I just want to write a for loop, okay, in C language. Assume that you have a for loop when I equals to 0. Okay, I less than n, I plus plus, you open the brackets, and you have the code, I will call this code A. This is a for loop. So this is, I can call it, instead of A, this is code A. Code A is a trunk of code. It's not only one instruction. It's some instructions, a group of instructions, okay? Whatever the code that you want to perform here, okay? How can I implement this in the assembly? Here is the question, okay? I know the jump instructions in addition to the compare instruction. How can I use those two instructions in order to perform this or implement this? Okay, so first of all, here I have a parameter called I, and the I is actually the index of the for loop. This for loop should be executed how many times? N times, because it's executed from I equals to 0 till I less than n. So the most important thing in the for loops is the number of iterations. You have to focus on this. How many iterations here? In this for loop, I have n iterations. Okay? So how can I implement this in my assembly language? It depends definitely first. If I'm assuming that n fits in one word, okay? So the n index, the number of iterations, is between, that means it is between, since it fits in one word, that means its value goes from 0 until the one word. The one word is how much? How much is the word? The word is 30. It's actually 2 to the power 16 minus 1. Okay? Some very big number. Okay? Anyway, This is actually 64k minus 1. Anyway, so first of all, I need an index in the assembly. So I have to pick some register to act like my index. This is number one. I need to, now let's put a design for our assembly code first. First, we need to initialize some register with the index of, or the for loop, with the iterations. Then we need to do the body of code A. Then we need to, so since we initialize some parameter to the number of iterations n, okay, we need to decrement the initialized register, the index register, or the iteration register. And check if it reach 0. If it didn't reach 0, I have to jump, okay, to continue. يبقى if reaching 0 no, يبقى continue in the loops. Yes, the code after that. So if I have here code for B, the code for B comes after the code, the for loop code. Let me just rewrite it here. So I have here the brackets, I have here code B. Okay, so I have for loop, code A should be repeated n times, and then code B. Okay, we will continue in code A. If it reaches 0, يبقى go to code B. Okay, so this is the design of my code. Assume that we will use maybe the CX register as my index. Okay, I can use any register, but I will use the CX. If I am using CX for my index, so here, so this is the high level. This is the assembly. So I will initialize with a CX. I have to move CX, comma, N. I initialized CX. Then I have to start the body of the code. So I have here code A. Then whatever code I have here. Okay, I have starting for the code A. Okay, then after I finish the code A, I need to decrement CX. We compare CX with 0. If CX equals to 0 means I already have done here how many iterations? N iterations. So here I want to use here I will use to conditional jump. Conditional, if the CX equals or CX equals means CX equals to 0. Jump if equal or jump if not equal, okay, depends where I want to jump. As long as CX is not equaling to 0, not equal to 0, I need to jump. To jump where? To go back to the for loop. يبقى jump. If not equal, as long as they are not equal, هعمل ايه؟ I will jump in to code A. Right. This conditional jump will go into one of two passes, either to the target if this condition is satisfied. If not equal, this satisfied, I will jump. But if those are equal, that means I will not jump. So I want to execute the code of B. Just this is right here. So here I have code B double dots and then the code. So this is a assembly implementation to this loop in the high level language. Since the for loop, by the way, this is not the only way to perform this operation. I can, instead of initializing Cx with n, I may initialize it with 0 and keeps incrementing Cx and comparing Cx with n. Okay? And again, jump if not equal to a to the code. So that means I will keep looping here until Cx reaches 0. I will stop and will not jump anymore and will continue. So there is multiple implementations for the same thing. However, we want to highlight something. For loops are used extensively in the assembly language. So that's why the developers of the assembly language have helped us and tell us, well, if you want to make a for loop, there is no need to write all of this code each time. Those three instructions can be replaced by one instruction called loop code. Those three instructions can be replaced by instruction called loop code A. If a loop code A, this instruction is assuming that your index for the for loop is the Cx and it is already initialized. And the loop will do three things. It will decrement the Cx, it will compare it with 0, and it will jump if it is not equals to 0 to that location. Okay, so this instruction is called what? It's called the loop instruction. Okay, okay, agree? And we can actually see this in slides. So let's go to the slides in order to kind of verify that we have learned here. Okay, so if we go here to the slides, we can see here the loop instruction. Okay, so loop instructions, loops and loop handling instruction. Cx must be pre-loaded with a count that represents the number of times the loop is repeated. Then loop is actually takes one operand or counter, which is the target location for the loop. Okay, and it is automatically keeps decrementing Cx, and it's doing a conditional branch instruction. So this is the typical usage for the loop, moving Cx some count and then do the body of the loop and loop to the next, and the next will be the label starting at the loop body. At the end of the loop, Cx will be decremented, and if it is 0, it will jump. If not, it will continue in the code execution. Loop also has two other flavors, which are called the conditional loop instructions. Okay, so we may take those instructions in later lectures. Okay. So I will defer discussing the conditional loop instructions in the following recording, or we may just finish them here. Let's finish them here. So conditional loop instructions. The conditional loop instructions is kind of a difficult instruction. Conditional loop instruction is actually looping based on two things. Okay, conditional loop instructions, we have two flavors conditional loops. We have loop if equal and loop if zero. The conditional loop instructions are actually instructions that are not only checking one condition, it checks two conditions. Okay, if those two conditions are satisfied, it will keep looping. If any of those conditions is broken, that means it will not continue in the loop. Okay, you can actually, this is a special case from the loop instruction. It's called what? It's called the conditional loop instructions. Conditional loop instructions, I have two flavors of them. I have the loop if equal or zero and the loop if not equal or zero. Those two instructions here, the CX is not updating the zero flag. The zero flag could be updated by another instruction in the code. So now, if I'm using loop E, that means CX is decremented, and the microprocessor checks two conditions for the loop. If Z is not 0 or equal and Z is 1, that means the loop will be taken and will be repeated. If the CX is 0, or Z flag is 0, that means the jump will not be taken. So only if the two conditions satisfy, I will keep looping. Okay, this allow you, so the main utilization of loop if equal or loop if Z is actually to allow you to terminate your for loop in the middle of the for loop. Okay, so you have two flavors for the loop. You have the regular loop, which will be performed in iterations. You have a conditional loop, which is actually can be performed a less number of iterations. So you have the zero flag to check for whether you want to terminate before the end or not. So at the termination of the loop E or loop Z, you may not have the Cx equals to 0. It may be not equals to 0 because actually maybe the 0 flag is 0, and is in that case I will terminate from the looping. There are two flavors for this, loop E and loop not E, okay, and both are doing the same thing. So this is actually an example here for an instruction that actually utilizes the conditional loop. The conditional loop instruction is actually help me in search. So I have an array of example here shows I have an array of, as you can see here, I have 15 elements, and I'm keeping incrementing CI, and I am comparing the elements of my array to some constant. Okay, so I can terminate from this loop according to one of the two conditions. Either, okay, I finish all the array of the 15 elements, okay, without having the comparison evaluated as true, or I found that one of the elements equals to DL, which is equals to 5. That means I will, so as long as they are not equal, I'm searching. Once I find it, I will terminate from the for loop. So this actually covers the loop instructions, and in the lecture number 2020, we will go into the other programming paradigm, high-level programming paradigms, the while loops, the if-else statements, and the switch cases. See you in lecture 20, inshallah.